Today I am going to teach you common language runtime. Friends, common language runtime, that is the part of the, you can also say that is the heart of the .NET framework. So if the .NET framework were a living, so breathing human being, the common language runtime would be the heart and soul. So every byte of code that you write for the framework either runs in the common language runtime or is given permission by the common language runtime to run outside the CLR. So nothing happens without the CLR's involvement. So CLR basically sits atop the operating system and provides a virtual environment for hosting managed applications. So when you run a managed executable, the CLR loads the module containing the executable and executes the code inside it. So code that targets the CLR is called the managed code, and it consists of the instructions written in a pseudo machine code and is also called the common intermediate language, or that is also called the CIL. So basically the instructions are just in time compiled into the native machine code, basically the 32-bit operating system at run time, and it in most cases a given method is JIT compiled only one time. So the first time it's called and thereafter cached in memory so that it can be executed again without delay. So code that is not called is never JIT compiled. So while JIT compilation impacts performance, its negative effects are migrated by the fact that a method is compiled only once during the application's lifetime, and also by the fact that the CLR team at Microsoft has goes to the compiled code output ordinary code, because the JIT compiler can optimize the native code and that it generates for the particular versions of the host processor that it finds itself running on JIT compiled code. So friends, basically the common language runtime, you can say that is the heart of the .NET framework. So whatever before that in the previous class we have seen that in the .NET framework we can execute any programming language. Any programming language means whatever language that directly supported by the .NET framework, like VB.NET, Visual Basic .NET, C#.NET, ASP.NET or JSAP.NET, but except those four languages we can also execute Visual Basic, Visual C++ and all any other programming languages also inside the .NET framework, just only because of the common language runtime. So why common language runtime क्या करते हैं? द कॉमन लैंग्वेज रन टाइम क्या करते हैं, जितना भी सोर्स कोड है, जो भी सोर्स कोड है डिफरेंट प्रोग्रामिंग लैंग्वेजेस का, वो सोर्स कोड को क्या करते हैं IL और इंटरमीडिएट लैंग्वेज में कन्वर्ट करते हैं. सो बेसिकली कॉमन लैंग्वेज रन टाइम कन्वर्ट्स ऑल द सोर्स कोड written by the different programming languages into IL or MSIL, that is called the intermediate language or Microsoft intermediate language. So the memory allocation and the garbage collection, you know what is garbage collections? Friends, garbage collections means what? The unwanted data. The unwanted data are stored into the unwanted location. So garbage values are stored inside the garbage locations. So basically in .NET framework, after certain times the unwanted files will be automatically deleted. So they are called the garbage value. So over 15 different languages supported today by the .NET framework, like C#, Visual Basic, JavaScript, Visual C++, Perl, Python, Smalltalk, COBOL. Do you know what is the full form of the COBOL? That is called the common business oriented language. Then I Haskell, Mercury, so many languages, Pascal and Scheme. So many different languages are directly supported by the .NET framework. So the common language runtime basically converts all those source code, all the source codes written by these languages to the IL or intermediate language. So that is the CLR or common language runtime architecture. So here you can see that base class library support. Here base class library basically used to store all the inbuilt methods in .NET framework. Each and every method which are stored permanently, which are inbuilt method that are stored inside the inbuilt class. So inbuilt methods are stored inside the inbuilt class, and inbuilt class are stored inside the inbuilt namespaces. So collections of inbuilt methods are stored into the inbuilt class, and collections of inbuilt class are stored into the namespaces basically. So after converting the CLR, it's divided into thread support, marshaller, type checker, and exception manager, debug engine, security engine, and then the MSIL will be generated. And after converting it into the IL or MSIL, it goes to the native compilers, that is called the JIT, and JIT convert it into the bytecode. And obviously class loaders are also used here. So that is the actual architectures of the CLR. So here that is the execution model of the CLR or common language runtime. In the first step, see, there are code in VB.NET, code in C#, code in any other .NET languages. Now if you are writing some source code using the Visual Basic .NET, so the VB.NET compiler is used to convert it into the IL or intermediate language. If you are using C# source code, so C# compiler will be used to convert it into the intermediate language. And if you use any other programming language, so the appropriate compiler, means compiler of that particular language, will be used to convert it into the IL or the MSIL, and then it converted into the CLR just-in-time execution. So friends, whatever language you want to execute in the .NET framework, the compiler of that appropriate language are used to convert the source code into the IL or MSIL, that is called the intermediate language or the Microsoft intermediate language, and then you can convert it into the CLR just-in-time execution. So that is the execution model. Here also same, Visual Basic compiler is used to convert it into the IL code. C#, the compiler of the C# is also used to convert it into the IL code or intermediate language code. C++ compiler is used to convert it into the assembly IL code, and unmanaged component that can be directly connected to the operating systems services. So here, after generating the intermediate language, common language runtime is used to convert it into the native interpreter, that is called the JIT, and JIT compiler used to convert it into the native code, and that is the actual execution model of the CLR. So how CLR works? So all the programming languages from the different programming languages like Pascal, VB.NET, C#, J#, whatever, all the programming languages are converted it into first IL, and base class libraries are also included. So IL, metadata, and base class libraries are converted it into the class loader, and then just-in compiler converted into the native code, and native code plus hardware requirement, memory management, bus security or execution support, these are mixed to the CPU and the program will be executed. So basic thing is that the first all the programming languages or the source code of all the programming languages will be converted into the intermediate language, and after that it is converted into the just in compiler, or that is also called the native code, and then the program will be executed by any CPU. So that is how CLR or common language runtime works. So next, Clr based execution. See here app.exe, that is called the executable file. Just in compiler, it converts into the object code. After generating the object code of an FCL components can be also included, and then it will be executed inside the operating system. So the common language runtime, that is the execution engine, compiles Microsoft Intermediate Language, that is called the MSIL, into native code. It handles the garbage collections, it handles the exceptions, it enforces code access security, it handles the verification, it may be managed code or the unmanaged code. So these are the some implications of CLR execution model. Clients need CLR and FCL to run .NET applications where available via redistributable .NET framework, and these are some design traits of. So CLR and JIT compiling, here indirect executions of .NET applications can be done. All .NET languages compile to the same CIL, and the CLR transforms the CIL to assembly instructions for a particular hardware architectures, and this is term is JITing or just in time compiling actually, and some initial performance cost, but the JIT code is cached for the further execution. So these are some advantages of the CLR, friends. First is the support for developer services. Second one, interoperations between managed code and unmanaged code, that is the COM and DLL. COM means component oriented model, DLL for dynamic link library. Next, managed code environment, improved memory handling, improved garbage collection. So these all are the advantages of the CLR. Improved garbage collection means what? After some time, suppose you allocated some memory space for some variables which you want to use for your program and program or in your source code. So when you allocate some memory space, so that memory space will be some memory space will be occupied by that particular variable. But after some times, if you don't use that memory space which are already allocated, so garbage collector destroy that particular memory space after some times. So that time in this way we can improve the memory allocations also. And using CLR we can convert any managed code and unmanaged code. Managed code means whatever source code which is directly supported by the .NET framework, they are called the managed code, and the unmanaged code means the source code which is not directly supported by the .NET framework, they are called the unmanaged code. So managed code or unmanaged code both can be converted to the IL or intermediate language by using the CLR. So that is also the advantages of the CLR or common language runtime. There are also another advantages. First is the JIT allows code to run in a protected environment as managed code. Just in time allows the intermediate language code to hardware independent. CLR also allows for enforcement of code access security. It is verifications of type safety and access to metadata. So these all are also the advantages of the CLR or the common language runtime. So there are basically the .NET framework requires that you use a language compiler that is targeted at the CLR, such as the Visual Basic, .NET, C#, C++, so JavaScript. So .NET compilers provided by Microsoft. Basically, note that there are a lot of third-party compilers on the market, that is COBOL, Perl, etc., and the number will continue to grow. So how does the code that you typed into the Visual Studio.NET become the code that user receives when it using your applications? So it is fairly simple and straightforward, So after using one of the language compilers, your code is compiled down to the Microsoft Intermediate Language, and then Microsoft Intermediate Language known as MSIL or IL. It is a CPU independent set of instructions that can be easily converted to the native code, and the metadata is also contained with the intermediate language. So the intermediate language is CPU independent. This means that the intermediate language code is not reliant on the specific computer that generated it. In other words, it can be moved from one computer to the another without any compilations. So this is what makes Xcopy or just copying over the applications are possible. After intermediate language, the code that you started with all will be compiled down even further by the JIT compiler to the machine code or the native code. So these are the different advantages. One thing I want to explain here also, that is called the JIT compilation. So the JIT compilation means the .NET framework contains one or more JIT compilers that compile your intermediate language code down to the machine code or code that is CPU specific. Basically, you will notice this process after you build your first ASP.NET page. After you build any ASP.NET page, you compile the page down to IL, and when you go to the browser and call the page by typing the URL in the address bar, you notice a slight pause of a few seconds as the computer seems to think about what it's doing. It is actually calling this IL code and converting it with a JIT compiler to the machine code, nothing others. So this happens only the first time that someone requests the page. So after the first time, if you hit F5 to refresh the page and the page is immediately executed, so the page has already been converted to machine code and is now stored in memory. So the CLR knows the JIT compiler has already compiled the page. Friends, so therefore it gets the output of the page from the memory. If you later make a change to your ASP.NET page, recompile and then run the page again, CLR or common language runtime detects that there was a change to the original file. So it uses the JIT compiler once again to compile the IL code down the machine code. So the JIT compiler, as it compiles to the machine code, make such that the code is type safe. It does this to ensure that objects are separate. So thereby making certain that objects won't corrupt from the other. So these are the code verification of the type safety. Code verification security is also the chip enable technology behind the CLR's ability to host multiple applications in a single process. A feat of a magic that it works by dividing the process into virtualized compartment called the application domains. So Windows isolated applications from one another by hosting them in separate processes. So an unfortunate side effect of the one process pre-applications model is higher memory consumptions basically. So these are the different advantages of the CLR or the common language runtime. Next is the common language infrastructure. So common language infrastructure, the first point is the CLI, that is called the common language infrastructures. So here C# source code, the compiler of the C# is converted into the CLI, and VB.NET code is also same. It is also converted by the VB.NET compiler, and JServe code is also converted by the JServe compiler. And then common language infrastructure first converted it into the common intermediate language, and then it converted it into the common language runtime. Common language runtime is used to basically to compile the CIL to the machine readable code that can be executed on the current platform. So basically machine readable form means, so these are the converted into the either 0 or 1. They are also called the object code. So common language infrastructure allows cross language development. Basically 4 components are needed. First is called the common type system. Second one is called the metadata in a language, and third one is the common language specification, that is called the CLS, and third one is called the virtual execution system. So friends, common language first we want to we will explain that is called the common type system. Common type system describes a set of types that can be used in different .NET language in common. That is, the common type system ensures that objects written in different .NET languages can interact with each other. So for communicating between programs written in any .NET compliant language, the type have to be compatible on the basic level. So these types can be either value type or the reference type. So the value type means where the value can be stored. Reference type means where the address can be stored. So the value type are passed by the values and stored it into the stack, and the reference types are passed by the reference which is stored into the heap. So here stack and heap both are two different memory locations, where in stack we can store the value, in heap we can store the address or memory locations. So common type system provides base set of data types which is responsible for cross language interactions or integrations. So the common language runtime can load and execute the source code written in any .NET language only if the type is described in the common type system, that is called the CTS. Friends, we want to explain another example. For example, if we are talking about the data type of the C and C++ language, so there are basically as a integer data type, 4 data types are used. One is called the byte, another is called the short, and in C and C++ only there are 2 integer type of data type. One is called the int, another is called the long. Here the size of the int data type or integer data type is 2 bytes, and the size of the long data type is the 4 bytes. Where in C#, when we are explaining the about the data types, here integer data types can be divided into 4 different types. where byte, short, int and long, and the size of the int data type is the 4 bytes. So see, in C and C++, the size of the int data type is the 2 bytes, and in C#, the size of the int data type is the 4 bytes. So that can be compatible. By using the common type system. That can be compatible using the common type system in .NET framework. So common type system is needed basically to avoid that type of problem. So another is the metadata. So friends, metadata means a modules can metadata is stored in a collections of tables, So one table that is the type def tables list all the type definition in the module. So type is a generic term of classes, structures, enumerations and other forms of data understood by the CLR. Another example of another table lists the methods implemented by those types, that is the another list the fields, another list the properties and so on. So by reading these tables, it is possible to enumerate all the data types defined in the module as well as the members each type includes, So additional metadata information is stored outside the tables in heaps containing the items referenced by the table entries. So for example, class names and method names are stored in the string heap. So string literals are stored in a separate heap called the user string heap. So together metadata tables and heaps define everything that you could possibly want to know about a module's contents and external dependencies. So the metadata format is interesting for an academic point of view, but it is rare that an applications developer use the such knowledge. So most applications don't manipulate metadata directly. They leave that to the CLR and to compilers. Applications that need to read and write metadata can do so by the insulate the developer from the binary metadata format. So one is unmanaged API exposed through the common interface, So the other is a managed API exposed through classes in the FCL system reflections namespace. So that is the actually metadata. And another is the common language specifications, So common language specification means it is a set of basic language features that the .NET language needed to develop applications and the services which are compatible with the .NET framework, where there is a situation to communicate objects written in different .NET component languages. So those objects must expose the features that are common to all the language. So common language specifications ensure complete interoperability among applications regardless of the language used to create the applications. So common language specification defines a subset of common type system. Common type system describes a set of types that can use different .NET languages have in common, which ensure that objects written in different languages can interact with each other. Most of the members defined by types in the .NET framework class library, that is called the FCL, are common language specification component types. So more of common language specifications basically standardized by the ECMA. So that is called the common language specification. Because of the common language specifications, we can execute all the languages inside the same platform. All the languages means those which are directly supported by the .NET framework, or those which are not directly supported by the .NET framework, they are called the third-party languages. So both can be executed in the same platform, that is called the .NET framework, because of the common language specifications. So friend, today here we want to stop, and in next lectures we will explain the assemblies and the detailed explanations of the CLS and the CTS. So thank you so much.